We're given the demand function d of p. We want to find the elasticity of demand at a price of $7. Then at this price, would we say the demand is elastic, inelastic, or unitary, also referred to as unit elastic? And then finally, based upon the results, to increase revenue, should we keep prices unchanged, lower prices, or raise prices? So if we take a look at the graph of our demand function for a moment, notice as the price increases, the demand decreases. So the elasticity of demand can help us determine whether we should raise prices, lower prices, or keep prices the same to maximize revenue. So for example, in this problem, the price is set at $7, and we can see our demand. So the question is, should we raise prices, lower prices, or keep prices the same to maximize the revenue? And depending on your textbook, the formula for the elasticity of demand can look different. In previous examples, we use this formula here, but for this example, I want to use this formula here. But before we do, let's compare to see why these are the same, because they do look quite different. Well, first, P stands for price. Notice how both have a P in the numerator. Next, D of P is equal to Q, and therefore this D of P in the denominator is equal to this Q here. The derivative of the demand function, d prime of P, would be the same as dq dp. So this derivative function is equal to dq dp. And because we want the elasticity to be positive, here we're going to take the opposite of this quotient because d prime of P is always negative. And this formula here, we're taking the absolute value. Either way, the result is that E is positive. So let's use this formula here and find the elasticity of demand function. So E, or E of P, is equal to the absolute value of P divided by Q, which is D of P, so 325 minus 2P squared, times dq dp, or d prime of P, which would be negative 4P. So we would have the absolute value of negative 4P squared divided by 325 minus 2P squared. And now since the price is 7, we'll find E of 7, which is equal to the absolute value of negative 4 times 7 squared divided by 325 minus 2 times 7 squared. And now we'll go to the calculator. We'll put the numerator in parentheses and the denominator in parentheses. So we have open parenthesis, negative 4 times 7 squared, close parenthesis for the numerator, divided by, in parentheses, 325 minus 2 times 7 squared. And we're taking the absolute value of this, so this will be approximately 0.8634. Now let's review what this tells us. The elasticity will be either less than 1, greater than 1, or equal to 1. And our value is less than 1, so we say total revenue is increasing at those p-values for which E is less than 1 and demand is inelastic. An increase in price will bring an increase in revenue. But just to review the other two cases, total revenue is decreasing at those p-values for which E is greater than 1 and demand is elastic. An increase in price will bring a decrease in revenue. In the ideal case, total revenue is maximized at the values of P for which E is equal to 1, and we say demand is unit elastic or unitary. So again, going back to our example, because our value is less than 1, we say the demand is inelastic. So for part C, to increase revenue, we should increase the price or raise prices. I hope you found this helpful.